And as you know, in the tradition that we've now established in this university, we also ask 3 younger scientists to come and talk to us and give their perspective, because after all, they will be around a lot longer than some of us will be. So can I ask Wen and Jessica and Joost, I'm not sure where you are, come, and give us your ideas. So, without further ado, and nothing bad about Matt, but they are the true highlights of this afternoon. Go ahead.
Hello? Everyone hear me? Yes. Okay. I am not going to stand behind this because I am a tiny person. So I'm going to stand here or maybe in front of it instead. I hope that's okay with everyone. I'm really happy to be here to be able to help open the year, especially when the topic is science as the basis of optimism. Have you ever asked yourselves, what makes you optimistic about science? I've never actually even thought about it, to be honest, until Louisa asked me that question when we met. So I did some thinking, and I decided to make this pitch into just answering that question. All around us, we have bacteria and viruses everywhere. We have them outside, we have them inside this room, and we even have them within ourselves, in our gut. Bacteria and viruses are constantly at war because viruses don't just infect us humans, they also infect bacteria. Fortunately for bacteria, they have their own immune system, and that immune system is called CRISPR. The discovery of CRISPR started about 20 years ago when scientists were looking through the DNA of a bacteria. And they started to notice something very odd. They noticed that there were very short palindromic sequences that keeps getting repeated over and over again. It's like you're reading a book and you come across the following. There were a lot of people at the party. There was Bob, Matt, Bob, John, Bob, Willem, and Bob again. Scientists were wondering, why are there so many Bob at the party? And what are they doing there? These scientists, they were optimistic that they will one day find the role of Bob. 10 years later, 2007, scientists found that Bob is involved in a defense system against viruses. Why? How? No one knew. This got a lot of people really curious, but at the same time, very much confused as to what they were looking into. Groups all over the world were working on this. Group from the United States, Canada, Spain, France, Scotland, and even Wageningen, the group I currently work in. My supervisor, John, not Bob, John, he was there. These groups, they would mail each other with questions that they had about their experiments. They would come together to discuss their latest results. Results just came out of the lab just yesterday. All this just to figure out how the system works. Again, these scientists, they were very optimistic that would one day find the answer. As years went on, they could piece together one by one the CRISPR system as a whole. And what they found was, when a virus infects a cell, CRISPR can find the virus, take a piece of DNA from the virus, and store it in its memory system. It will store it in between 2 Bobs. And then we'll take this memory system that I found and use it to find the virus and cut the virus, eliminating the virus from the cell. While scientists were thinking about CRISPR and how it works, it hit them. You can reprogram CRISPR to not find and cut the virus, but to find and cut somewhere else. that's somewhere else. It can be plant DNA, it can be bacterial DNA, and it can be even human DNA. Scientists took a part of an immune system and use it to modify human DNA. And that's how CRISPR technology came to be. A technology that lets us modify DNA efficiently, precisely, and with more ease. We can soon start healing genetic diseases such as sickle cell anemia, Duchenne muscle dystrophy, and cancer using CRISPR technology. And to think that this actually all evolved from a group of curious scientists doing great fundamental research, scientists that never gave up their optimism in finding a solution. That's amazing. To answer the question, what makes me optimistic about science? Fundamental research makes me optimistic about science because fundamental research can lead to extraordinary technologies. And in my opinion, fundamental research is the basis of optimism. Thank you. Thank you for the great applause, and I will give the word to Jessica.
Thank you, Wen. Your enthusiasm is contagious. As we lead up to the celebration of 100 years of this university, we're being called to think about the contributions of science to the world. And it's clear, science and scientific progress offer a strong basis for optimism. Yet alongside all of the wonder and wisdom and progress, there are rational reasons to be cautious of adopting an optimistic trope. Technologies today can be differentiated from those of the past, insofar as they are more powerful, more all-encompassing, and more impossible to avoid. We just heard about a technology that can fundamentally change who we are. Anthony Giddens, former director of the London School of Economics, has shown that our societies are now marked by high levels of risk that involve high levels of human agency involved in both the production and mitigation of these risks. He calls these manufactured risks. At this university, we are at the cutting edge of many scientific and technological advancements. We are also aware that there will be good and bad outcomes as these technologies roll out. There are enormous uncertainties and complex dynamics. With new discoveries and advancements in science comes responsibility. With radical science comes radical responsibility. As we push forward with these exciting developments, we are also increasingly aware that we can no longer afford to get it wrong. The consequences are simply too great. We need to proceed with caution. This means we walk a very difficult line in science, one we sometimes try to ignore. We need to be true to our methods, to our ambitions, to our instincts, but we also need to be aware of public value. What's more is that these values differ, and at times they are irreconcilable. This reminds us that science and scientific technologies have politics. To be clear, our job is not to say what these politics should be, and we should maintain our independent positions as much as possible. But we do need to engage in deliberation about them. If science is to be with and for society, we need to be actively deliberating amongst ourselves and with others. We need to move outside of our comfort zones and have difficult conversations about the direction we want society and science to take us. To do this, we need to know what kind of future we want. So I propose we use the tool of utopia. Utopia is used to describe a place where we might desire to live. To imagine utopia, that is to formulate alternative scenarios to reimagine how to live on this planet, it's an active response to some of the key problems we face, both real and imagined. Now, imagining utopias is not a childish or a naive pursuit. Louise Fresco has remarked that utopian thinking is indeed so powerful that it cannot be dismissed as unscientific religious doctrine or naive mythology. Carolyn Steele argues utopianism represents the nearest thing we have to a history of cross-disciplinary thought. And the physicist John R. Platt has noted the world is now too dangerous for anything less than utopia. Imagining utopias can expand the number of places we look to make sense of the world. Utopias can be used as a tool to experiment with the multiple, with broad experiences, and to foster dialogue around ideas and values that matter to people. In this way, designing utopias can move us from the monoculture of scientific knowledge to what Santos has called ecology of knowledges. To design a utopian society means to be at once imaginative and optimistic, but also critical and subversive. It is through proposing utopias, challenging utopias, and reimagining utopias that we can come to foster fundamental conversations about the future we want and what this future will look like. And this is key, because science will continue to solve problems, many of its own creation, and economies will likely continue to grow, but they may not lead us to the society we want. Let us reflect a moment on the mission of our university, to explore the potential of nature to improve quality of life. Applying the tool of utopia, we may find that there is no consensus around what quality of life means, and that we have ignored much of the diversity of values, of ambitions, and aspirations of people the world over. Further, to improve quality of lives, we need to identify potential risks and problems before they happen. We also need to engage in the very difficult process of assessing related trade-offs. We are no longer in a moment where we can maintain a blind faith in science or the mechanisms which mediate the outcome of our science. And at the same time, we now face a very difficult task of rebuilding public faith in science. So let us be creative with our visions. Let us continue to develop interdisciplinary, science-supported pathways towards these visions. But in doing so, let us be wise, and let us wonder about the implications of our science. Let us move forward with reflection, deliberation, and caution. And finally, let us remain optimistic. As Jean-Claude Servet said, the hour calls for optimism. We'll save pessimism for better times. I'd like to pass the mic over now to Joost.
As an ecologist, I will now reflect on positive impacts of science and development in a field that is, due to species population declines, often loaded with pessimism. And in many ways, I think the world that we live in today is still a world in which ecologists, even those with a great fantasy, would like to live, would desire to live, because there is still much diversity to be amazed about. Now take, for example, the bovids. These are animals with horns, animals, cows, sheep and goats, gazelles and antelopes and all their relatives. And I have here a field guide, a book that lists all the species one by one, page by page. And you can already see by the size of it that there are many species in this group. If you go through it and look at all those species, I cannot do anything else than be amazed, because I see the variety in body size, body shape, I see the different coloration, I look at the antlers, and I'm just wondered of all this diversity that still exists. There are other ways to look at the field guide. When a friend of mine visited Southeast Asia, he took along with him a bird field guide, and he noticed already that the forest was rather empty. But he found some locals being very enthusiastic about his book. But soon he was to discover that their enthusiasm was based on their hunting experience, and that their species that they looked at were discussed in terms of the quality of the meat. So where are you? If we take this field guide and use it either as a restaurant menu card on the one side, to on the other side a reflection of the utopia that we are still living, albeit fragile, where are you? And I would like to rephrase the question of how many species within this book. And these authors identified 279, others do only 143, but let's stick to the point that there are many. How many species can we afford to let go? How many species should go extinct before we start feeling uncomfortable? For me, the question is 0. I don't want to let go any of those species. And I think for many, if not all of you, the same is true. And why do I find this interesting? Because even though there are so many, and even though they are all a bit alike, we care about each and every individual one. Even more so, and that's what I found even more intriguing, is that many of those books, I suppose, are unknown to most of you. Many of those species in here. 279, perhaps you know 20, perhaps 30%. And yet we care about each of them, each of those species. I think that this shows that in our society there's a strong basis for conservation, a strong emotional basis. And I think that this basis is the product of a society that can afford itself, after scientific developments, to care about species other than itself. A society that, truth be told, does destroy, but at some moment starts to set aside areas for nature, to control hunting, and even to build bridges. Bridges costing €1 million just for wildlife to cross over highways. So in such a society, it is possible that wildlife makes a spectacular comeback, as we see now in Europe. Not all species, we should be very careful about that, but many species do make a nice, spectacular comeback. Yet there are important considerations. And one is that the land that is left for animals, the nature area that they can roam in, is still very small. We just heard from Matt Ridley that positive projection is that nature areas will increase. As it is at the moment, nature area is marginal. Marginal in terms of the location on the sites, little connectivity. Marginal in terms of the size, only small pockets of forest remaining. But also marginal in terms of the quality. Because the good soils, the fertile soils, have been taken by agriculture. So our group is now working on methods to increase the quality and quantity of forests and wildlife reserves, so that it can sustain a higher population and higher density of wildlife. And here I think we match a goal that many of us are working on in this university, namely to increase the biomass of food on as little land as possible in a sustainable way. And we more or less mimic that, but we are producing biomass of wildlife, producing diversity. I see here a common denominator for working on the quality of life. And when we hear the positive story, or at least the positivism advocated by Matt Ridley, I think what he basically is saying is that he's trusting us. He's trusting us scientists and students of Wageningen University that we will increase, that we continue with the advances made in science, and that we will work on those issues where until now we fell short. And when we think of the quality of science, I think we should do so from an inclusive perspective. We should, first of all, of course, think about humans, but also we should think about animals in this book. The wild ones and the domestic counterparts that we use as production animals, and we should think of all animals, all other animals with which we share this earth. Thank you.
Thank you so much, Jessica, Wen, Joost. That was a marvelous set of presentations. And one thing you did is not only present yourselves, but what I should say that when we approached the three of them to come and speak, the first thing they did was to get together and talk together. And that is, in a way, practicing one Wageningen in one go. You're doing it, you're talking. So as a token of our respect and pleasure, we are going to give each of you a book. And let me see, this on that. Of course, I mean, books. What else? But we also have flowers. Thank you very much. Here we go. When? So can I have another round of applause for these wonderful people? Thank you so much. Thank you. Thank you. Please.